In this video, we'll be looking at Boolean Algebra. We use Boolean Algebra as it's a simpler way of looking at and writing more complex logic diagrams. We can also use laws to simplify Boolean expressions in an attempt to reduce the number of logic gates. The NOT gate in Boolean Algebra is represented by the input letter with a line over the top. The NOT gate inverts or flips the inputs to the opposite. So a 0 becomes a 1 and a 1 becomes a 0. The AND gate in Boolean Algebra is represented by one input with a dot followed by the second input. So A dot B. You can think of the dot as a multiplication. So 0 times 0 equals an output of 0. 1 times and a 0 gives an output of 0. An input of 0 and 1 would give an output of 0. And an input of 1 and the other input of 1 would give an output of 1. The OR gate in Boolean Algebra is represented by an input plus the second input, so A plus B. The OR gate could be thought of as addition. So if we had an input of 0 plus an input of 0 would give us an output of 0. An input of 1 plus an input of 0 would give us an output of 1. An input of 0 plus an input of 1 would give us an output of 1. And an input of 1 plus another input of 1 would also give us an output of 1. Because we're in binary and we can only have a 1 or a 0, when we do 1 plus 1, we would only get an output of 1. The XOR gate in Boolean Algebra is represented by the input with a plus sign with a circle round, and then the second input, so A plus with a circle round, B. This basically follows the same XOR as we use in the diagrammatic version of the logic gate, so that if the two numbers are equal, then our output would be 0. So if we have 0 input plus a 0 input, then our output would be 0. If we had an input of 1 plus an input of 0, then our output would be 1. If we had an input of 0 plus an input of 1, then our output again would be 1. And if we had an input of 1 plus an input of 1, then that would give us an output of 0.